Morning lads, the next installation we're going to do is the cable tray and SY cable. As always, you need to write down the method statement, tool list, materials list, PPE and the safety precautions that we put in place. I'm now going to sand down the filler that I applied last week. The last thing to do is just remove off the rough edges and the job's complete. The tools that we're going to use is a level, a Phillips screwdriver, a small flat-headed screwdriver, a large flat-headed screwdriver, 2 adjustable spanners, a metal file, a hammer, adjustable square, a scribe, a piece of chalk, permanent marker, punch, a small level, a tape measure, a pair of side cutters, a drill, an electrician's lock knife, a crimping tool, a hacksaw and a 7mm metal drill bit. The materials we're going to use is a piece of tray, the width may vary, a commando socket, 16 amps, 2 20S SY glands, 2 pieces of uni strut, the depth is 20mm, 2 Zebedees, a piece of brown and blue sleeving, 1 6mm yellow ring crimp, three M5 bolts, one M5 nut, eight wood screws, some 1.5mm earth wire, and some 1.5mm SY cable. The aim of this task is to get over an obstacle with a piece of tray work. Okay, so the first thing I'm going to do is I'm going to cut the tray down to 600mm, that's 60 centimetres. I'm going to use my adjustable square to make a 90-degree line. Using a block of wood, I'm going to put the tray work into the vise. The reason why I use the block of wood is to stop the tray work from bending when I put it inside the vise. When using a hacksaw, it's important that you don't cut the item at a sharp angle. Using my thumb to keep my saw on the line, I'm going to slowly start making an indentation. If the saw gets stuck while cutting, just lift the saw out, reduce the angle of the saw and start again. Make sure while you're cutting that you're keeping on the line. When using a hacksaw or any piece of metalwork, it's important that we use a file to remove all of the burrs. The burrs left on the metalwork could damage the cable when you're installing it. I'm going to flip the tray work over so that you can see where I'm putting the measurements. The first measurement I'm going to do is 10 centimetres either end of the tray work. And then I'm going to measure 15 centimetres or 150mm up from the 10 centimetre mark, and that will be for the slopes up to the obstacle. Leaving me 10 centimetres in the middle to go over the obstacle. Once again, I'm going to use my adjustable square to mark out where the cuts need to be. Next thing I'm going to do is I'm going to mark the lip of the tray work. So this is where I'm going to be making my cuts. I'm going to put the tray onto its side, and following the lines that I've drawn, I'm going to use my square again and mark out where I'm going to be making my cuts. And same on the other side. And now I'm going to put this piece back into the vise and make cuts along the lip of the tray work. I'm going to make my first cut here. Again, I'm only going through this piece of the tray, not the back of it. And the same on the other side. Once you've made your cuts, we need to make sure that there are no sharp edges left on these. Okay, once it's been filed, we can start forming this piece of tray work. As I've said before, we're going to try and get over this obstacle. And there's 2 pieces of unistrut that need to be fitted to either side. So the last thing we need to do is we need to bend these 2 pieces outward to keep it parallel with the top piece. The next thing we need to do is fix the piece of tray work to the wall. The way we do that is by using something called a zebedee and some unistrut. The zebedee is pushed into the middle of the unistrut and rotated so that it fixes itself into the middle. The next thing we need to do is we need to drill a hole into the tray work for a bolt to go through that will screw onto the zebedee. So I'm going to mark 5 centimetres in on both sides. And 2.5 centimetres in, which will put me in the middle of the tray. Once I've measured out the centre of this piece of tray, I'm going to use a centre punch and a hammer to put a small indentation into the tray to help me start drilling. The next thing I must do is to select a drill bit that's going to be large enough for the bolt to fit in. I've selected a 7mm drill bit. I'm going to use a piece of wood underneath the tray work so I don't go through the table. The next stage is to cut and terminate the SY cable. We know that the cable is going to be at least 600mm long, because that's the length of the tray. But we also need to make sure that we've got enough wiring to go inside of the consumer unit and be terminated, and also enough wiring to go inside of the socket and terminated. So I'm going to measure how much wiring I need inside the consumer unit. I'm going to add 30 centimetres. And I'm going to add a little bit of cable for the socket, let's say 15 centimetres. I'm going to add another 150mm to compensate for the gap between the consumer unit and the tray and the socket. I'm going to mark both ends, one at 300 and the other at 150mm. Using a knife, I'm going to gently score around the outer sheathing, bend backwards and forwards and pull it off. Now that that's done, here comes the slightly laborious task of unravelling the braiding. Let's go through the parts of the gland. First is the shroud, then is the gland itself, 2 washers, a banjo and a lock ring. The shroud protects the gland. The gland is what holds the cable into the accessory. It has a gasket inside which prevents moisture from getting into the cable and into the accessory itself. The 2 washers go either side of the braiding. The banjo either earths the braid or earths the accessory that is being connected into. And the last thing is the lock nut or lock ring that holds everything in place. Twist the braid into 2 parts and slide them through the 2 slots on the gland. I've slowed this down so you can take note of the knot that I'm making, as it can be quite confusing. First link the 2 pieces over and feed the other one back through the loop that's been created. This creates a sort of figure of 8. Pull the 2 pieces together and they will clamp tightly around the gland. As I previously stated, it's necessary to use a banjo to earth the outer braiding of the SY cable. However, there's another way of doing this. As you can see, the cable is being terminated into a metal enclosure. In this case, it's a consumer unit. If we remove the paintwork around where the cable is being terminated, we are able to maintain continuity of the CPC without the use of a banjo. Now that enough paint has been removed to maintain good continuity, we can get on with terminating the cable. The insulator inside the SY cable is quite soft. Be careful not to damage the wiring while you're removing it. As you can see, this cable utilises numbers rather than colours to identify the wires. I'm going to snip off the excess braiding. Feed it through the consumer unit and apply the lock nut. I'm going to use my 2 adjustable spanners to tighten the gland into the consumer unit. I'm now going to tighten up the bottom part of the gland, which seals the gasket. And lastly, put the shroud over the top of the gland. Utilising some tie wraps, I'm going to fix the cable onto the tray work. As it's going into a plastic enclosure, a banjo must be used. I've drilled through and put a bolt through to the other side and attached an earth wire to the inside of the box. I've not recorded this step as it's fairly simple. Just select the wiring that you're using. In this case it's a 1.5mm earth wire. Make sure the wiring fills the crimp. This could mean doubling over the conductor, and then on the crimping tool it's colour coordinated, so if you're using yellow crimps, which we are here, just put the crimp into the yellow slot on the crimping tool and crimp it down. Once everything's screwed back and you put the shroud over the top of the gland, it's a simple case of attaching the socket. As you can see, this cable utilises black wires. They're identified with a numbering system. There's numbers printed along the wires. This means you can identify where the wires are going at both ends of the cable. I would recommend using the number 1 wire as the live and the number 2 as the neutral. The last thing we need to do after we've installed the socket is to select the breaker that we're going to be wiring it into. Unfortunately, SY cable isn't recognised by BS 7671, so I'm going to have a look at the armoured cable, which states that a 1.5mm armoured can take a maximum of 22 amps. As this is a flexible cable, the current carrying capacity and the volt drop changes. So I'm going to reduce the maximum current carrying capacity by 5% to give me a close approximation of what this cable can handle. This gives me the answer of 20.9 amps. It's with this in mind I'm going to select a 16 amp breaker to protect this circuit. Thanks for watching this video. I know it's been a slightly longer one. Don't forget to answer those questions.